Hi guys, so today we'll be solving this problem called uncrossed line. It is something similar to what we did yesterday, edit distance, which is also similar to LIS problems. So let's read it. We write the integer of a and b in the order they are given on two separate horizontal lines. Now we may draw connecting lines, a straight line connecting two numbers a of I and b of j, such that a of I is equal to b of j. The line we draw does not intersect any other connecting line, non-horizontal line. So note that the connecting lines cannot intersect even at the endpoints. Each number can only belong to one connecting line. Okay, return the maximum number of connecting lines you can draw in this array. So basically, we have been given two arrays, A and B. Now we have to connect both the arrays and see how many connecting lines we can draw. Connecting lines are drawn between the elements which are same, same in both the arrays. So for example, 1 and 1 is same in both the arrays, so therefore the connecting line would be drawn. Similarly, 4 and 4 is the same, therefore connecting line. And 2 and 2 and 2 and 2 are also same, but we cannot draw a connecting line because we have already drawn a connecting line which passes between 2 and 2 line. So therefore we cannot cross a line. That is the condition. Uh, Similarly here we have 2 and 2, 5 and 5. Okay, first wait. 5 and 5, 1 and 1, and 2 and 2. So this makes it 3. Similarly here 1 and 1, and then I can see 5 and 5. So 2 you can draw here. So what we'll do is something extremely simple, similar to what we did in LIS. How we check that we'll be considering from the last element, and we'll check if the n minus 1 element is equal to m minus 1. If they are equal, at that time we will be increasing the the number of crossed line at that particular index, which is 1 plus dp of nm. Otherwise we will be checking that what is the maximum between dp of n minus 1 m and dp of m minus 1 m. Okay, so first I'll do the memoization code, and then we'll do the tabulation code. Let's do it. So int n is equal to a dot size, int m is equal to b dot size, and then we'll create a vector int. We are creating a 2D vector because we are storing two elements or two arrays, length of two arrays, and then vector int, okay, m plus 1 minus 1. Okay, we'll initialize it to -1, and then we'll return max uncrossed lines memo a b n m dp. Okay, now similarly what we'll do next is that we'll create int max uncrossed lines memo vector int and a vector int nv int m int m vector int and dp. Okay, now this is what we have defined the memoization function. Now we'll write the conditions. So as I decided first that we'll be writing the condition that if a of n minus 1 is equal to b of m minus 1. So if we found the elements are equal, so what we'll do is we'll return dp of n m is equal to 1 plus, we'll pass it to the next element and to check if what is the max and cross line for them. Okay, and accordingly we'll update the current current dp. will also go to n minus 1 and m minus 1 and dp. Okay, now we'll check otherwise that return dp of n m is equal to max of max uncrossed line memo a b n minus 1, whoever is the maximum, we'll get that either n minus 1 or a b n or m minus 1 dp. All right, and now since this is done, we'll return dp of n m. Okay, now let's write the conditions, which is the base condition. So if, as we write in all the memoization function, if dp of nm is not equal to minus 1, at that time we return dp of nm. And one more base condition would be there. So say suppose n also becomes 0 or m also becomes 0. So both of the length, either of the length, if they become 0, so then at that time the dp size, dp length would be 0 only. So which will be the base condition. Okay. Now let's run the code to see if it's working. Okay. Where? Got line 21. Yeah. Okay, that works. All right. So the memoization works. Now let's do it the tabulation way. So tabulation is extremely same what we did here. We will be running two loops, plus plus into j is equal to 0, j is less than or equal to 1, j plus plus, and now we'll be checking the same condition what we checked here. If I is equal to 0 or j is equal to 0, at that time dp of ij will be equal to 0 and that time will be continuing. Okay, now we'll also check here if a of I minus 1 is equal to b of j minus 1. At that time dp of I j would be 1 plus dp of I minus 1 j minus 1. Okay, now this is extremely same to what we defined as a condition here. Okay, if this doesn't happen, then at that we will be creating an else condition and we'll put dp of I j is equal to max of dp of I minus 1 j or dp of I j minus 1. All right, and then we'll simply return dp of n m. Okay, now let's see if this works. Yeah, that works. Yeah, it is a bit faster than memoization. So I hope you guys understood the problem. It is extremely same to what we did in LIS. The same condition we are checking here, that is we check that we used to check of the string n minus 1 and m minus 1, and here we are checking for the array. So it's extremely same to what we did in LIS. So I hope you guys understood the problem and do solve it. Thank you.